Thank you for joining Noble's virtual conference. And I like to think that we have the best for the last. So hopefully you stick around for this presentation. I think it's going to be extremely fascinating. I want to introduce D-Wave, and we have Alan Barrett's with us, the CEO, and John Markovich, the CFO. And without further ado, I want to turn it over to Alan. Thanks for joining us.
Thank you for the opportunity. We're looking forward to the discussion today. As Michael said, my name is Alan Barrett. I'm the CEO at D-Wave System, and I'm delighted to have the opportunity to tell you about it. Let me take a minute to tip my hat to our attorneys and then forward. So when it comes to quantum computing, we are at a watershed moment for the industry. We are just now making the transition from research experimentation to production use of quantum computing. But frankly, there's only one company in the world that can make that statement, and that is D-Wave, because we are the only company with quantum computers large enough and powerful enough to actually support real business applications at commercial scale. And so while other companies in the quantum space talk about government research grants and academic partnerships as revenue, we talk about companies like Vinci Energies or MasterCard or Interpublic Group or Pattison Food Group as customers that have worked with us on real business applications to benefit their business operations. D-Wave is a full-stack quantum computing company. We do everything from designing and manufacturing our quantum computers. Our current generation system is called Advantage. It's a 5,000 qubit quantum computer. It is accessible through our Leap quantum cloud service. That's our own quantum cloud service that we developed not just for research experimentation, but to support real business applications in production. In fact, we have had to pass multiple security audits before our customers would use this system, and we have been successful at passing those audits. So this quantum cloud service was designed for the availability, the privacy, and the security required to support commercial application usage. We have our own suite of software development tools called Ocean. They are all open source so that our customers can help us to evolve the tool suite. And we have a professional team with our customers through our quantum launch program to help build and deploy quantum applications. We have a large and growing base of customers, as you can see here, and we have a very significant IP portfolio. We have over 200 US granted patents, over 100 in process worldwide. In fact, we're number 3 for quantum patents behind only IBM and Google. Our Advantage quantum computer is the world's largest and most powerful quantum computer, is what's known as an annealing quantum computer, and we're the only company in the world that provides annealing quantum computers. Everybody else that's pursuing quantum is pursuing a different approach, which is probably 7 to 10 years away from commercialization. So that gives us a huge head start on the commercialization of quantum. Moreover, our annealing quantum computers are very good at solving a class of problems known as business optimization problems. Things like workforce scheduling or supply chain logistics optimization. And they represent a significant and important portion of the market. And we now know, because it was proven mathematically a couple of years ago, that annealing quantum computers are required for optimization problems. You solve them with the other class of quantum computers that others in the industry are working on. And finally, we have recently demonstrated quantum supremacy on our annealing quantum computers. In fact, we're the first company to demonstrate quantum supremacy on an important real-world problem. It was a material simulation problem. All other attempts to demonstrate quantum supremacy were done on contrived problems, and they were all proven to be flawed. So not only are we the first company to demonstrate quantum supremacy on an important real world problem, but we are the first company to actually demonstrate quantum supremacy. The market for quantum is very, very large. Boston Consulting Group estimated it to be at 2 to 5 billion in the near term, growing to 450 to 850 billion in roughly the 20-year timeframe. They estimate that about 20% of that is what's available to the quantum hardware, software, and services providers. So that's us and the other quantum companies. So call it 500 million in the near term, growing to about 150 billion in the 20-year timeframe. Moreover, BCG did divide the market into 4 technology areas: optimization, I talked about that a minute ago; linear algebra for machine learning; factorization for cryptography; and differential equations for simulation and quantum chemistry. As I mentioned a few minutes ago, annealing is required for optimization. And D-Wave is the only company in the world that provides annealing quantum computers, which means we're the only company in the world that can tap into that portion of the market, which represents 25 to 30% of the total market for quantum. That's available to D-Wave exclusively. All the other companies that are pursuing quantum are pursuing a different approach called gate model. Gate model is required for differential equations, so they exclusively can go after that portion of the market. But then there's about 50% of the market that's accessible to either annealing or gate. By the way, we announced at D-Wave that we are also building a gate model system so that we will be the only company in the world delivering both annealing and gate, as well as the only company in the world that can address the full market for quantum. And finally, as on the first, we are the only quantum company that is commercial today, and we will likely be the only commercial quantum company for 7 to 10 years, because that's the time frame that it will take to get a gate model quantum computer to market supporting commercial applications. So what about the types of applications that we can address in the market today? There are 2 different types of application categories: what I call evolutionary applications and what I call revolutionary applications. Revolutionary applications are things like global weather modeling or drug development. These are applications that are so computationally intensive that they're not even being worked on today. By the way, no quantum computer today, including the D-Wave quantum computer, is powerful enough yet to address these applications, although we will get there. That brings us to the evolutionary applications. These are things like scheduling, customer loyalty rewards optimization, HVAC design, promotional tour routing. These are applications that companies are addressing today, but they are computationally very challenging. So challenging that classical computers cannot solve them optimally. So companies use heuristics to try to come up with what they hope are good enough solutions. But with our quantum computers, our annealing quantum computers, these are the types of optimizations that we can address today, and we are addressing today, allowing us to provide better solutions faster for our customers to reduce their operating expenses or increase their revenue and deliver a positive return on investment. A recent study done by Hyperion Research, just published within the last week or two, this was a survey of about 300 large and mid-sized companies. Roughly 95% of the companies surveyed said that they are investing between $3 and $6 million a year in quantum today, and they each expect on the order of a 10 to 20x return on that investment over the course of the next 12 to 18 months. So the market is absolutely ready for quantum, and investments are being made today. Much of this investment is research experimentation, to be fair, because only D-Wave can provide real production application support. But we expect that over the next 12 to 18 months, as it becomes more well understood that D-Wave is able to support commercial applications today, we think these investments will start transitioning to production apps and to D-Wave. Just to give you some examples of some of our customers and some of the work that we are doing with them and the benefits they're seeing. Pattison Food Group, a Canadian grocery chain, has in production today 2 applications leveraging our quantum system. One is for e-commerce grocery delivery, and the other is for workforce scheduling. And they're seeing roughly an 80% improvement in performance on both of these applications. Interpublic Group, a large ad agency, one of the things they do is put together promotional tours for large companies. Leveraging our quantum computers, they are able to compute the routes for these tours in about an hour, when it used to take them 12 hours to compute the tours. Vinci Energies, a large construction company in Europe, has used our to be able to do a better job of designing HVAC systems for large buildings. Leveraging our systems, they are able to design HVAC systems that are lower cost and more aesthetically pleasing, and they can compute the designs significantly faster than what was required with classical computers. We've done a fairly extensive analysis of many different applications and which of those can benefit from our quantum systems today, which of them will be able to benefit from future generations of our quantum systems. With our current Advantage quantum computer, 5,000 qubit quantum computer, the types of applications that can best benefit today basically revolve around resource scheduling and resource allocation. And you can see on this chart, as we bring new versions of our technology to market, it will enable additional applications and use cases. I want to call your attention to machine learning in the 2025-2026 timeframe. When we put this chart together, we believe that that would roughly be the timeframe when our quantum computers could be used in support of machine learning model training, basically to develop more accurate models, as well as train models with lower energy consumption, as well as a few other areas of improving machine learning. In just a minute, I'm going to explain why we think that's actually accelerating. We'll be able to start addressing that at the end of 2024 and early 2025. But that brings me to Advantage 2, which is our next generation quantum computer. We've been working on this system for the last couple of years, and we are very close to delivering it. In fact, we have recently delivered a small prototype version of this system into our quantum cloud service so our customers can start experimenting with it. This is a 1,000 qubit version of our Advantage 2 system. Our Advantage 2 system has greater connectivity than our Advantage system. So our Advantage system allowed for degree 15 connectivity. Each qubit was connected to 15 others. With Advantage 2, each qubit is connected to 20 others. That means it can support larger and more complex problems. Our Advantage 2 process also has higher coherence. It has roughly 2x greater coherence time than Advantage, and with error mitigation, that adds another 10x for a 20x increase in coherence time. Increased coherence time, faster time to solution. And finally, we have an increase in energy scale of 40%, which means we can specify problems with greater precision and come up with higher quality solutions. So our 1,200 qubit Advantage 2 prototype available in our cloud today for customers to start working with has more connectivity for larger problems, higher coherence time for faster time to solution, and higher energy scale for higher quality solutions. And in fact, we have a 4,800 qubit version of this process that is in calibration in our lab today, and we expect it available very soon on our path to the final 7,000 qubit production version of our system, which we expect to see next year. Finally, with our Advantage 2 quantum computer, this is the system that we have been able to use to demonstrate quantum supremacy. As I said, this is the first time that any company has been able to demonstrate that a quantum computer can solve an important real-world problem, in this case, material simulation, where it would take classical computers millions of years to solve the same problem. It's just not feasible to solve it classically. We worked with experts around the world in all of the classical techniques to solve this problem, and we were able to get time from Oak Ridge National Lab on the Frontier supercomputer, which is the fastest computer in the world to perform this research. Basically, what the center graph shows here is that the material simulation that we performed on our quantum computer in about 20 minutes would take well over 1 million years to perform on the Frontier supercomputer. Moreover, and maybe even more interesting, is the graph on the right. This same computation would require well over global annual energy consumption. So not only are we capable of computing solutions much faster than they can be computed classically, but we can compute them with much lower energy consumption. And this is critical because it is this result that has opened up the door for us to accelerate our work on generative AI model training to come up with not only more accurate, but lower energy consumption machine learning model training. I'd also like to point out that up until now, the majority of our sales and revenue have been commercial, unlike everybody else in the quantum industry, which is really focused on government research grants and government sales. However, recently, there have been some laws that have gone into effect. Congress passed the National Defense Authorization Act that was signed into law just this past December 2023, and they are now working on renewing the National Quantum Initiative and a new Defense Quantum Acceleration Act. All of these acts explicitly call out the need for defense to start working with annealing quantum computers. So this is opening the door for us at D-Wave to pursue opportunities in addition to commercial opportunities, which is a significant upside opportunity for us. So we feel like as we look to the future, there's opportunity for us both in continuing to grow that commercial business that we've gotten off to a great start building, and we're the only company that actually can pursue that today, as adding government opportunity into that. With that, I'd like to turn it over to John to spend a few minutes on the financials.
This is a highlight of our Q1 operating results, which we announced in mid-May. In the upper left-hand corner, you'll see that our year-over-year increase in our quarterly bookings was up by 54%. And the first quarter of this year represented our 8th consecutive quarter of year-over-year growth in bookings. Bookings also increased substantially on a sequential quarter-to-quarter basis from Q4 of last year to Q1 of this year. And then our revenue on a quarter-over-quarter basis was up by 56%. In the lower left-hand corner, you'll see a very significant increase in our gross profit. We have a very high degree of operating leverage inherent in our business, so we see pretty meaningful improvements in gross profit and margin with growth in revenue. And The center chart here at the bottom, commercial revenue, this outlines the magnitude of traction that we are making in our commercial efforts. And by the way, we are the only quantum computing company that discloses this level of detail on our customers and our commercial traction. So for the last 12 months that's ended in the first quarter, we had a total of 125 customers, 75 of which were commercial customers. 25 of those are Forbes Global 2000 companies, and our commercial revenue was up by 51% on a period-over-period basis. And for the 4 quarters ended in the first quarter, 70% of our total revenue was derived from commercial accounts. From a liquidity perspective, we ended the quarter with a little over $27 million in cash, but when we reported our first quarter earnings, we disclosed that we had cash of $33 million. Subsequently, we filed a $175 million shelf registration statement in April that also went effective in April, and then we amended that for a $100 million at-the-market facility that has been operational since the very end of May. In addition, we had about $82 million remaining on an equity line of credit that we put in place about a year and a half ago. So we now have roughly $250 million of SEC-approved equity issuance facilities.
Thanks, John. So I just summarized by saying we think we're executing quite well across all areas of the business, from technology to product to science with our quantum supremacy result to go to market. And you can see the numbers here. With that, I'll turn it back to Michael for Q&A.
All right, thanks, Alan and John. Fascinating presentation. I appreciate it very much. I do want to mention that if you do have a question, feel free to use the box at the bottom of your screen and send in those questions. We'll be polling for questions. And so, and I see that a number of them are coming in, but let me go ahead and ask a couple. Can you just kind of expand on your quantum supremacy? How will this impact your traction with customers and then speed up adoption?
Yeah. So obviously, our customers are always interested in trying to understand how much heavy lifting the quantum computers are doing in solving their problems. And so the quantum supremacy result just helps them understand how powerful these systems are. And then as we engage in discussions with them, we can help to draw the analogies between that and what we can do for them with the problems that they're struggling with and they're trying to solve from a computational perspective.
You know, AI is such a big buzzword, but I know that your company is kind of like the backbone of AI, if you want to look at it that way. Can you talk a little bit about the opportunity with AI, and in particular, what you're doing with this Zapata AI?
Yeah. So I think there are 3 areas in which quantum and AI come together. 2 of them I've already talked about, 1 I haven't. 1 is quantum can be used to build more accurate models. So we can basically improve the accuracy of machine learning and generative AI. The reason is when you use quantum to train a model, you're training on a quantum distribution rather than a classical distribution. And quantum distributions have more degrees of freedom, so you can get a better fit to the model. Second, with quantum model training, we consume less energy. This was seen clearly in the supremacy graph that I showed, where it just consumes far less power to compute solutions than using classical. Same is true with machine learning model training. Far less energy consumed. The third is quantum and AI working together. So for example, AI in the supply chain is very good at demand prediction. So you could use AI to predict product demand, and then you could use quantum to optimize the supply chain to meet that demand. So these are three different examples of quantum and AI coming together.
I'm curious, in your presentation, you mentioned about governments, and I was wondering if you can talk a little bit about, you also highlighted this announcement with Davidson and that they're using your product. And I was just wondering, what does that potential announcement and what that might mean for your government business?
Yeah. So yeah, the starting point with government is really to help them with their mission applications, which is quite different from what all the other quantum computing companies are doing with government today. Essentially, what's going on today is that government is providing research grants to help fund the development of their systems. But for us, when we talk about engaging the government, it's really to help them solve their mission problems. And that's what we are going to be pursuing. Some of these mission problems are, not sensitive. For example, scheduling employees at the Department of Homeland Security, TSA, for example. Some of them are sensitive. For example, missile defense. The relationship with Davidson that we had last week is all about putting a system in a secure facility at their site in support of sensitive applications.
Gotcha. And then in terms of, I was just wondering maybe if you can elaborate a little bit more on the implications of applications transitioning into production. I know you talked a little bit about that. Why is this important? And where is the balance between quantum computing, that industry, relative to transitioning the applications into production?
Yeah. So for D-Wave, there are two elements to our business. One is professional services, where we help customers build applications that can leverage our quantum systems. The other is quantum compute as a service, where they're basically just paying us on a recurring revenue basis to access the quantum computers through our cloud service. For us, the revenue that we really want is the quantum compute as a service revenue, because that's much more stable recurring revenue and much higher margin revenue. So we think of professional services as the on-ramp to quantum compute as a service. Professional services to develop the apps, then once they move into production and the customer starts using them to run their business, it becomes quantum compute as a service revenue. So that transition to production is very important to us from a business model perspective, because that's when it becomes very sticky to the customers. They're running their business on it, and we're getting multi-year recurring revenue.
I know investors like to look at milestones, so I was wondering, what are D-Wave's key product and technology milestones that investors should think about over the next 12 to 24 months, let's say?
Yeah. So from a product perspective, it's all about getting Advantage2 into the market. We're making progress with that. We've got a 1200 qubit version in our cloud service. We'll soon have a 4500 qubit version on our way to 7000 qubits. So it's about getting Advantage2 into the market, because that opens up some new use cases for us. Second, it's about moving applications into production, because as we move applications into production, not only do we get that higher margin recurring quantum compute as a service revenue, but the customers become referenceable, and that then allows us to accelerate the time to sign up new customers and get other applications into production. It gets the flywheel going.
Gotcha. And I'm going to weave this question that came in from the outside audience here. Why are there not more competitors in annealing quantum computing? There's obviously a lot of companies investing in quantum computing these days. And what are the primary competitive barriers to entry at this point?
Yeah. So there are huge barriers to entry at this point. First of all, we've been working on annealing quantum computing for 15 years. So we've got a massive head start, and we're not standing still. Moreover, we've got a huge patent moat, over 200 US granted patents, another 100 in process. So it will be very hard for anybody to successfully compete against us in the annealing space. We're starting to see some companies now spring up, now that we've kind of proven that it can be done. and we're starting to see the success, but it's going to be very hard for anybody to compete with us in this space.
And I was wondering if you can, you touched on this, and I was wondering if you can discuss D-Wave's plan to design a superconducting gate model quantum computer. If you could just kind of give us a little bit more color on that.
We announced that a couple of years ago, basically so that we can address the full set of use cases for our customers. Frankly, we've developed a lot of technology for our annealing quantum computer that is directly applicable to a scaled, error-corrected gate model system. And so while we're starting a little bit later than everybody else in the gate model space, we frankly have technologies that they haven't even started working on yet that are going to be required for a gate model system. So we think we'll be able to move at least as fast as anybody else in this space. And we're off to a good start. We've basically demonstrated high coherence qubits. We've demonstrated a new approach to reading out answers from the qubits that's 20 times faster than anything that anybody else has done. And so we're off to a good start.
I know we're running a little bit over, but I'm going to sneak one more in, which I think is a really important question. Why should investors be interested in quantum computing now versus in the future when the technology has matured and use cases, revenue models, and that sort of thing are more established?
Because it's going to happen very fast. I mean, we are now at the point where we've got a significant number of customers. We have worked through proofs of concept. We're moving to production. That flywheel is going to start going pretty quickly. So, either now or you lose out.
That's terrific. And with that, that's a great answer and a great closing, Alan. Thank you very much. Thank you, John, for participating in our conference. We greatly appreciate it. And we look forward to monitoring your progress. It's a fascinating field.
It's been fun.
Thank you, Michael.
Thank you so much.
Bye-bye.